In this video, we're going to talk about Tower of Hanoi, which is an extremely classical puzzle in both math and computer science. So, just in case this video is a little bit long, but don't worry, we will be chopping up this video into these sections. So, yep, without further ado, let's go. Okay, so Tower of Hanoi, a very famous puzzle, but not exactly everyone heard of it before. So here are the rules. In this case, this puzzle is this thing. Yep, I made it. It has two parts. The poles, we get 3 of them. This one, and that one. And then the rings, which is these. Now, your main goal is to move all of these 6 rings from this side to this side. Now, you might be thinking, yeah, it's just easy. I can just grab it and just place it here, grab it and then just place it there, and then boom, eventually all be. But actually, no. There are actually several extra rules in order to make this puzzle. The first thing first is no larger ring can be on top of any smaller ring. That is the main forbidden rule. If you saw anyone playing Tower of Hanoi with a bigger ring on top of smaller ring, you know they are failing spectacularly. Now, second rule, all of these rings can only appear in one of these 3 rods. Not on the floor, not on your hands, like what I'm doing. No, you can't do that. Not on your coffee mug. This is not a donut. Don't do it. And then the final rule, which is when you have a ring stack, okay, it could be anywhere. You can only take what's on the top and then move it, put it on top of any of the ring stack. You cannot take somewhere else from the bottom or in the middle or somewhere else. You can only take what's on the top. So those are the 3 rules. Okay, so we can start with solving a 2-ring puzzle and see what it looks like. It doesn't have to be like that many rings. We can start simple. 2 rings, ring 1 and ring 2. So solving a 2-ring puzzle, it will be something like move ring 1, ring 2, and a ring 1. Extremely simple with just this. Okay, what about ring 3? So this is where I would just do, this is ring 3 right over here. So let's try this again, but with 3 rings and see what it's like. So basically, let's take a look at this. Ring 1, ring 2, and then ring 1, and then ring 3, and then move ring 1 again, and then move ring 2, and then ring 1. So there we go. Now, of course, we can just keep on adding more rings, and then of course more steps you have to go through. And then most of the people, when they think about this, they're just gonna be like, oh, okay, more rings you go, alright, more steps, you need more brain power to squish in just to figure it out and stumble upon the correct answer. But actually, it's a small trick. Let's go back to the very beginning of the 3-ring puzzle. Now, one thing that you might be able to notice when we are solving a 3-ring puzzle, we are actually solving a 2-ring puzzle twice. Didn't see it? Let's try again. Now, I'm solving a 2-ring puzzle. And then, I move this one. And then, I'm moving another 2-ring puzzle. Or solving another 2-ring puzzle. Done. So here's the pattern. A single Tower of Hanoi puzzle can be broken down into solving a smaller one, then move that ring, and then solving a smaller one. So if we know how can we solve a 3-ring puzzle, then we can solve a 4-ring puzzle. But in order to make things a little bit easier to understand, let's label things. Now, for naming convention, let's call this rod left, rod middle, rod right. Okay, your left, your right. Not mine. Mine's flipped, but doesn't matter. Start, middle, end. Okay, right now you cannot see my face, or you know what, that doesn't matter. Boom. Okay, so for a 2-rings puzzle, both 2 rings start here, and then they should end here. So this rod has to be the middle one. Alright, so let's say right now we will start recording the steps. We do not record, alright, this one goes to middle one or the right one. No, we don't record that. Instead, we will record, hey, is it going to the end or the middle or the start? Soon you will see why. So let's record that. This one goes to middle, this one goes to end, this one goes to end. Now we have that record. I will video edit that somewhere else, I don't know. Now with that, we can start solving the 3-rings puzzle, if I got it right. Oh, I think I messed up a little tiny bit. No big worry, we're still in good shape. Okay, so there we go. So this is where the 3 rings should start. Let me just move it over here, move it over here, and then there we go. Okay, so we have ring 1, ring 2, and ring 3, if we got that right. So right now this is where ring 3 should start, and this is where ring 3 should end, and this is where everything happens, right in the middle, you know. Right now we have our ring 2 solving steps recorded. So now also at the same time we will be recording the ring 3 steps. However, we are going to refer it by using the ring 2 sticky notes. So right now our first step is to actually move these 2 rings from this thing to this one. So from the 2 rings perspective, this is the start, this is the end, and so the middle is over here. Now we can refer to our own recordings. Move 2 ring middle, 2 rings middle, 2 rings end, 2 rings end. Alright, now also at the same time we have to like record these rings for the 3 rings puzzle. Of course I will video edit that. Now we will move this from here to here. Record this for the 3 rings, not the 2 rings. Now we have that. Our main goal is to move these 2 over here. So right now, yeah, this is the start, and then this is the end, and therefore this rod will have to play the middle rod role. So now just want to make sure that, okay, good. So right now we will do here, going to the middle, going to the end, going to the end, and there we have solved the 3 ring puzzle. And then we can actually keep on going and then have all the steps recorded. So by using the same idea, I can actually then say, alright, with this, let's solve a 4-ring puzzle. So, alright, I have set things up a little bit. So right now we're solving a 4-ring puzzle, but we have the 3 rings puzzles recorded. So right now we can solve this 3-ring puzzle first. We're gonna move it from here to here. So this one needs to be the middle. So let's go. First, I will have to do whatever I need in order to move those 3 rings from here to here. Now I can move this to here. Now I can then do this and then continue. Ta-da! And so if we have our 4-ring puzzle step recorded, of course we can solve the 5-ring puzzle, 6-ring puzzle, and so on. Okay. Ooh, I hope your brain is a little bit warmed up. So let's go. Okay, so as you can see, a Tower of Hanoi puzzle containing smaller versions of itself. In this case, you can see that this is recursion. If you haven't watched the video of us talking about recursion, go take a look at that and then come back. Now, back to this. The reason why we say that this thing is recursive is because the first step is just solving a smaller ring puzzle. So in this case, we have all 6 rings over here. You just need to like move this one over here, this one over here, one over here, this one over here, one over here. As you can see, at this moment I am cheating, but I'm just trying to tell you we have to do whatever we need to do in order to move n-1 rings from this one to this one. And then we will be moving this one to this one. And then we have to do whatever we need to do to move the rest over here. Oh wait, did I got it right? Yeah, somewhere around there. I don't know. So, and then in order to move those rings, they have to like call a smaller version of itself. And then if this keeps on going, eventually it will hit the base case, which is moving 2 rings. So yeah, that's the base case, and this is why Tower of Hanoi is recursive. Okay, so at some point, maybe you're in college or university or maybe high school, you were assigned to prove, hey, find a formula that if I give you the number of rings, use that formula to tell me, hey, how many steps do we need in order to solve that puzzle? So, here's the thing. And most of the textbooks or articles online just tell you, hey, use proof by induction. Problem with induction is you will need to come up with a assumption. Like for example, I assume that this thing equals to whatever string we have. Now the problem is it's extremely hard for us to come up with that string. So for me, a better method is the direct proof. So right now, let's just came up with a function h of n that will tell you the steps required in order to solve a Tower of Hanoi puzzle with n rings. And just to be clear, set the base case, we don't want any stack overflow happening. H of 0 is 0, because when you have no rings at all, You don't even need to move. It's done. So now let's take a look at h of n. h of n, how do we solve that? Well, step 1, we will need to move n minus 1 rings from this rod to this one. How many will that take? h of n minus 1 moves. And then we will move the big ring from this rod to this one, so plus 1. And then we have whatever n minus 1 rings in the middle. We will use h of n minus 1 moves to move whatever this pile is from this rod to that one. So we have h of n is h of n minus 1 plus 1 plus h of n minus 1. Now rearrange this. Of course, we have 2 times h of n minus 1 plus 1. So that is the recursive things that we can prove. Now from there, let's see if we can reach h of 0. So in this case, now h of n minus 1, we can actually say, hey, that is actually 2 times h of n minus 2 plus 1. Alright, let's do that. And then let's multiply whatever outside the bracket or parentheses into the parentheses. And then we have that. Okay, pretty cool. Hey, and then I can then say h of n minus 2. Hey, it's actually 2 times h of n minus 3 plus 1. Okay, and then just multiply whatever number is outside into the thing. And then one thing you might notice is at some point we will reach 8 multiplied by h of n minus 3, and then plus 4 plus 2 plus 1. And then we can keep on tumbling down, but one thing you might notice, that number right in front of the Hanoi function is actually 2 to the power of let's say right now is h of n minus 3. You see this 3 over there? Now look at that 8. It's actually 2 to the 3. And then the rest of the pile is 4 plus 2 plus 1. Okay, cool. Let's go one iteration more and then you can see the pattern. Right now we have h of n minus 3. Let's recursively call that again h of n minus 4. So we have 2 times h of n minus 4 plus another 1. We got that 8 outside, bring it in, it's now 16, which is also it's 2 to the 4. That 4 over there matches the 4 in n minus 4. And then this 1 becomes 8. And then it joins the rest of the pile. 8, 4, 2, 1. And then we can keep on tumbling down. So this means that, okay, if we were to reach h of n minus, let's say a, then the number in front of the Hanoi function is actually 2 to the a. And then the rest of the pile is 2 raised to the a minus 1. And then 2 to the a minus 2, a minus 3, a minus 4, so on until you end up with 4, 2, and a 1. So this also means that when we reached h of n minus n, which in this case let a become n, what will happen is that number in front of the Hanoi function will be 2 to the n, and then the rest of the pile is actually just 2 to the n minus 1, n minus 2, n minus 3, n minus 4, and so on. So what is h of n minus n? h of n minus n is actually h0, which we just declared it before. It's the base case, it's 0. So poof, gone. Now we have h of n is those powers of 2. Okay, pretty cool. Now on both sides we can add 1. Once we have that, look at those big pile. 1 plus 1, that's 2. 2 plus 2, that's 4. 4 plus 4, that's 8. It will keep on adding up and piling up together, and in the end we will get 2 to the power of n. So 2 to the power of n, and then we have h of n plus 1. Oh, we're pretty close. We just need to move that plus 1 onto the other side, and then we will end up with h of n is 2 to the power of n minus 1. And there we go. So let's take a look at this. 6 rings. Yes. So if we were to bring this thing in, 2 to the power of 6. Let me do this. 2, 4, 8, 16, 32, 64. 64 minus 1, 63. So you will need at least 63 moves in order to move this pile of ring from here to here by following the Tower of Hanoi rules. So we have that. Alright, so yeah. Well, at first, or through what we have seen, Tower of Hanoi is extremely recursive. You have this like puzzle calling 2 versions of the smaller puzzles and then go on. However, this can actually be solved iteratively. Now in this case, I'm going to introduce 2 quote-unquote functions or protocols or procedures. The first one is cycle tiny. So cycle tiny so what it means by cycle tiny is the smallest ring, it will cycle through the rods. However, there are 2 ways to do it. Either we go left, middle, right, left, middle, right, left, middle, right, or we go left, right, middle, left, right, middle, left, right, middle. So that is cycle tiny. Now, the next procedure, what I would call it, is called switch remain. So, which is something like find the tiny ring, which is this one. Do not care what is on the stack, whatever. What you need to care is the rest of these. Move 1 ring to another rod. In this case, this one has no ring at all. So, move this one to this one. There we have it. And then, in order to solve this puzzle, it's just actually these 2 procedures taking turns with this cycle tiny thingy starting first. So I can actually demonstrate this. Are you guys ready to see me solve this? 63 steps. I don't know. Hope this works. Let's go. Cycle tiny, switch remain. 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 Mid checkpoint. That is switch remain. Okay. Cycle tiny, switch remain. 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 cycle tiny, switch remain, 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 cycle tiny. And there we have it. So as you can see, all we need to do is to just switch in between cycle tiny and switch remain, with cycle tiny doing it first. However, keep in mind, when we have even number of rings, cycle tiny goes left, middle, right. When we have odd numbers of rings, it's the other way around, which is left, right, middle. So another way to like memorize this, which is a hack, is because this works for any numbers. Let's say we are only solving a Turing puzzle. We just do this, that, and then this, and then you can see, hey, cycle tiny is moving from here to here directly, so you can know, 2 rings, that's even, so it's left, middle, right. You just need to remember this, so every time when it's even, left, middle, right. Otherwise, left, right, middle. Okay, so here we have it, the iterative way to solve Tower of Hanoi, and now you can actually train yourself to solve it, so because now you know. Okay, so perhaps you have tried the how should I say this? Perhaps you have tried, hey, solving the Hanoi puzzle. It's actually quite easy now by using the iterative method without, you know, squeezing your brain really hard. So right now there's actually an alternative version of the puzzle. Originally, rings can just move from one rod to another whatsoever, however you like, but now in the alternative version, rings are only allowed to move from one rod to an adjacent one. You cannot skip rods, you have to like go to the adjacent one. So solving a Turing puzzle would be something like ring 1, ring 1, ring 2, ring 1, ring 1, ring 2, ring 1, ring 1. So as you can see, it takes way more steps. And as you can see, if you saw that pattern, you might know how to solve any numbers of them. Because here's the trick. In order to solve this, I will have to do whatever I need to do in order to move these 2 rings over here, which is this, this, this. And then I will have to do it once again to move this ring, this pile, from here to here. Oh wait, did I? Okay, and then I will move this one over here. And then I move these 2 over here. And then I will move these 2 over here. And then this one over here. And then I will move these 2 to the middle one. And then finally completing the puzzle. There we go. So that's the recursive part of it. And then we can tidy up a little bit and then just perhaps possible came up with a new formula. And that's an exercise for the viewers. But don't worry, eventually I'll just type it out in the description whatsoever. So yeah, that's one of the alternative versions of Tower of Hanoi. And yes, internet is an amazing place, and I'm not the only one who make videos like this. There are other popular ones. Now, just in case if you don't know, Numberphile made another video of Tower of Hanoi, and it actually explains, hey, there's actually a pattern. But of course, there are some other amazing rules about Tower of Hanoi, so go give that a watch and then see if it can help you a little bit, like, you know, getting inspired. And 3 Blue 1 Brown also made a video talking about Tower of Hanoi, and somehow it matches up the way how we count in binary. So you can actually go take a look at that and then, yeah, get inspired. And optional request, press the like button on those 2 videos. Yep. So yeah, a while ago I made this Tower of Hanoi puzzle over here and have some of my friends play it. Some of them they love it, some of them
我突然觉得我脑袋又不够用。
Look, Razor, it has to be that pole, okay? For my dignity.
Okay, it is progressing. It is. I feel like I did it in a like stupid way.
If I remember correctly, it was something like the
your first step is wrong.
然后 S 就默默看着我。
Okay, no. Look, I'm smart, okay? I'm not that much of a dumb.
Now we're talking.
No, I didn't mean that.
哦不，我明明刚刚知道他是怎么过去，但我现在忘记他要怎么回来了。不。
Come on, think. Why can't I be like Jimmy Neutron? Okay.
That's not good. We missed one. Look, it's almost. It's. Yeah, no, I guess I need to like redo it now because I missed the biggest one, the second biggest one.
Come on, man. You're a med student. You're smart enough to do this.
1, 2, 3, 4, 5, 6. I don't know why I'm counting.
Yes.
That's stupid.
There we go.
Okay.
Nah, it's okay. You're just breaking a bigger problem into a smaller one. So that's actually the essence of this thing.
This is the opposite. Yeah. Okay, sorry. Yeah. It's so hard to actually. Okay,
Nah.
perfect.
Move this right here. Move this right here. Move this right here. Wait, this is bigger than this. Oh, I thought it was smaller. Oh, fuck. Oh, that's what I was trying to do. I was trying to move that.
不就对了？天哪，我是白痴哦！这个东西我居然弄那么久。
Oh, now this one. Now we going. Now we going.
Ah! Yes. Okay.
Okay, yeah, I need to put that one there. Okay. Which?
Shut up! I know. Okay. I know. Shut up! Don't say nothing.
So, yeah, and when they first saw this, they were like, ooh, this is a nice little toy, what should we call it? I told them, it's Tower of Hanoi. Some of them, okay, yeah, cool, Tower of Hanoi, cool. Some of them, they say, no, I will call this cake blocks. Like, how is this cake? I don't know, but if you were to call this a donut, yeah, fine, I'll let that slip. So, that day, I remember couple of years ago, when I managed to prove h of n is 2 to the power of n minus 1, the first thing I immediately think of is, what will happen if we have another pole? This is a pen, I know, UV pen, but let's treat this as a pole. So if we were to have 4 poles, okay, what would it be like? So solving a 6-ring puzzle, originally you will need 63 steps. But right now, let's challenge this and see how many steps we can reduce. Ready? Let's go. So that's 1, 2, 3, 4, 5. And then we can do the 3-ring puzzle here, here, here by using these 3 rods. That was like 5, right? 1, 2, 3, 4, 5. Yeah, 5. And then 6, 7, 8, 9, 10, 11, 12. And then the 3-ring puzzle. Or wait, no. 12, 13, 14, 15, 16, 17. So we go from 63 to 17. Now, is 17 the most efficient steps? I don't know, so that's actually something for everyone to burn their brain a little bit. So yeah, there we have it. Okay. Alright, let's quickly wrap this up real quick. Alright, so let's quickly wrap this up. Tower of Hanoi, recursive puzzle. Way to solve it, you move n-1 rings from this rod to this one, move the big one from this one to that one, move whatever pile in the middle to this one over here. There we have it. Recursive formula for Tower of Hanoi. H of n is 2 times h of n-1 plus 1. And then with that we can actually prove h of n is 2 to the power of n minus 1. With that said, alternative version, ring can only move from one rod to an adjacent one. That's even more steps. Sometimes, for fun, you can actually add a 4th rod over there and see how it goes. So yeah, we have that. Alright. Alright, there we go. If you're watching this video to the very end, thanks for watching. If you like this video, this may sound a little bit annoying, but if you like this video, please hit the like button. If you want to see more math videos from us, hit the subscribe button or whatsoever. So, yep. Alright, I guess this is it. Alright, see you all in the next episode.
好了，写出来了。SR 花多久
刚刚这个
？SR 还有多少？SR。有，听得到了。
Man, fuck this. Yeah.
Nice, nice, nice. Yeah,
there we go.
perfect. One, I'm gonna make
Yes.
it easier like this.
Yes.
It's gonna be faster.
Yes.
And then 1,
There we go.
2.
There we go. Yay! 5 minutes, but not bad.
Yeah! Yeah! I did it! I did it! It probably was like at least twice as many steps as it needed to be. Yeah. At least I did it.
See you all in the next episode. Bye bye.